I hope you had a good tour of the telescope. I think my program predates Fred's one, because the AAT is named as the Australian Astronomical Telescope. He's actually the Anglo-Australian telescope. And I wanted to just correct or clarify something Bob said this morning, that the AAO doesn't exist anymore. That's true, it's not true. About 15 months ago, the federal government, as part of a new policy change, agreed that Australia would join the European Southern Observatory, which is one of the biggest players in world astronomy, and they run big telescopes for optical and radio in the deserts in Chile. They're based in Germany. And Australia's been trying to join that consortium for well over 30 years. And the government finally bit the bullet and said yes, they would join. We paid for the membership of the ESO, the European Southern Observatory, for 10 years. But unfortunately, the government said it couldn't afford to both pay the membership for ESO and keep the AAO Observatory. And so it said to the Australian Astronomical group that if you wanted to keep that going, the research sector, that is the universities, would have to look after the AAO. So the AAO started off as the Anglo-Australian Observatory, hence the Anglo-Australian Telescope. It then became the Australian Astronomical Observatory, and then as from 1st of July this year, it ceased to exist as an organisation. But obviously, it's still operating. So what's happened is that telescope operations here at Silent Spring, the AAT, and the Schmidt, which is just across the way there. That's not the clamshell one, but the one on the farthest to the left of that way, the UK Schmidt. They're still operating, and they've been taken over by the ANU, Australian National University, which owns all the land here and runs most of the telescopes up on the hill there. And all the staff who worked here for the old AAO are all now ANU staff. So still thriving and still operating every night and observing. And those of us who are based in Sydney, the other site that used to be the old AAO, where we do the astronomical research and build instruments, survey instruments for telescopes around the world, including this one, and also the astronomy data archive and warehouse and management. We will be taken over by Macquarie University. So we have both regions. So we're called the Australian Astronomical Optics, MQ. So we're still at AAO of sorts. So yes, after 44 years, the observatory did land, and a lot of old timers who looking around the room who worked for the AAO for many decades, and Fred and myself also worked for the AAO for a long time. And that's been a big change for us from being an integrated organisation that did telescope operations, observations, built instruments, tested them on our telescope, and also had all our researchers coming in. So we're no longer one organisation. But life is full of change, and we're off to doing different things. And yeah, the future's looking quite rosy for us. Otherwise, we face the world. So, we're still here, but we're not here. Pretty serious. And I also wanted to, I think Bonnie may have mentioned, but I also wanted to thank New South Wales Planning Environment for the grant they gave us for the LRA to run a project to promulgate the dark sky guidelines, which Fred and I kicked off. And we found some money down the back of the LRA couch to top up the grant and to keep it rolling along. And then we got Barney on board and worked with Barney, you know, to stand aside and tsunami that is sweeps past you. But anyway, that money helped us get to the stage where we got the conference up and running. So I suppose in one sense that's the end of that project, but hopefully this is not the end, because there's a lot of awareness now of lighting and the dark skies, and certainly the dark skies part and all the work that's being done here won't stop. So it's a bit of a long-winded clarification, but I sort of acknowledge that environment. So we're moving on to our afternoon session, and I suppose part of the job is to keep people awake in post-lunch session, so we'll keep chopping. Our first speaker is Tim Shotbolt, who is actually a local lad, graduate of Burnaway Public School, which is just down the road, and then he graduated from Coonabarabran High. But thankfully, he didn't rest on his laurels. He moved on to do lots of other things. So I'm going to ask Tim to take us through the first session for the afternoon.
I'm not going to go into what the frustration. If you have questions from human frustration, I know some of the answers. I know why. I'm more than happy to talk about that. But working together to improve our environment. So I'm going to tell you a story as to how I got there and why a land conference, where all these disciplines come together and discuss the different aspects, is really so important. So, well, you can see that there was one lonely oil lamp in Sydney in 1826. Coal oil, by the way, it's the same as canola, but it just has a few things. It's not really desired. And canola is just Canadian and oil in the one thing that they've used sometimes. And you can see the progression in 1 year, and gone to 100 of them. But then gas lamps came along, and that was each one of those was equal to 8 times the light output of the old oil lamp. But then this is riding the light wave technology. This is what we've done as a human species. And then you can see that when the gas came along, they then invented a mantle that tripled. So now the gas lamps were producing 24 times the amount of light for that single oil lamp was producing, but we've increased the quantity. And then came along carbon arc, which is 5 times that. So now you're talking about 120 times the light output of just a single oil lamp. But interestingly, you think places like Sydney should have been the first places to have it, but no, that's not the case. In 1888, Tamworth on DC electricity had the first carbon arc lamp, and then Young had the next one in 1891. And it wasn't until 1904 that Sydney first went along that route. So what's carbon arc? In the publications in Sydney at the time, everybody was marveling how brilliant light and light it was compared to the environment. But if this is the area of our concern, this is blue part. The blue curve is actually carbon arc, and the blue part of the spectrum is also not divided. It's like the welding arc. So not only that, they were very dangerous. They caused lots of fires and fevers and other things. So that's where technology was, but everyone thought it was really wonderful. What happened? Well, 100 years later, we now have 612,000 high-intensity discharge streetlights in New South Wales. Right? The majority in the major road lighting is high-pressure sodium, that's very orange kind of light. A third of them were mercury vapor. Minor roads, the majority of them are mercury vapor, but then you had fluorescent, but it's the old style, the halo phosphide fluorescent, which was a bit less colorating but had a blue spike. But they're not the only luminaires. They're car parks and cycleways and airports and public parks and all these sports lighting applications here. So that's how we got to our current predicament, is we just have many more of them. So there's high pressure mercury. Fluorescent, there's your blue area, a reduction with the better color rendering fluoride. This is high pressure sodium. Look how small the component is of blue light. But interestingly, guys in Sherbrooke in Canada and Aylan counting lit by high pressure sodium. But that's lit by LED. It looks like high pressure sodium, and they're observing it safely because people that produce that could actually remove that little tiny bit of glue, and so the timers were, should I say, but this is, you know, we've seen that's done 5,000 Kelvin LED, you can see. So what else contributed? Well, you can't read this graph, but this is New South Wales. In 35 years, from 1960 to 1985, we have 12 times the alternating current electricity consumption. So this technology, in fact, you can generate and broadcast electricity over long distances by using alternating current. Has allowed distribution of electrical devices what they are. The other curve is just the other states. And then the other artificial light source is from gas flares. And you go, okay, yeah, but they're offshore, and yeah, sure, they have a few lights on these things, but so what, there's only one or two. Yep. There's light droppings on that map are oil and gas wells. And that's some time ago. So it is something we need to consider. And there's the other factor that somebody else will probably be talking about is this is population growth happening pretty much the way that it's happening. A lot of it's by immigration. The only one that's changed from that time is this is prediction curve, but it's actually no more parallel. The loss of mining booms decreased. You say, yeah, so what? Well, this is something that caught my attention some time ago because I was around when this was proposed. This is called Biosphere 2. It's meant to be a completely sealed environment. It cost something like $84 million to do back in the end of the 1980s. And what it was an environment that represented completely sealed, no outside air, completely sealed. So you can see that they had a representation of rainforest, marsh, ocean, savanna, desert, and some forestry, and a little bit of human habitat. And so they put some humans in that environment. But first of all, they took them out to sea for 6 months and put them in very closed environments to make sure that they were the right people that could live together and not kill each other in the process. Unfortunately, what happened was that this very expensive experiment failed, right? Because they underestimated the little things. Has concrete slabs built on concrete slabs. They underestimated the amount that the carbonation process that goes on in concrete extracted oxygen out of the environment. They thought, oh, that's okay, because the trees and other things in there will reproduce that. But it didn't happen. After 12 months, they had to feed oxygen into that environment because it was equivalent of working at 8,000 feet elevation. But the people persisted. But unfortunately, that meant that most of the pollinators died. So things were not going to get pollinated. So then what happened? Well, the sort of weeds took over. And then, I don't know whether it was the Australian contribution, but somehow or another, some ants hatched in there and the ants took over. So it was the little things that made this fail. And this is my concern. If they didn't understand that, they'd invested so much money. What hope have we got? So what do we actually know? Well, from clear sky over here to the full moon, that's about 1 million to 1, the difference. And then you've got starlight here. But we perceive this mostly through our eyes and our experience. But the problem is that's in from 380 to 780 nanometers. But what happens in the blue ultraviolet? Lots of species can actually see equally well there. So what we can't see, they see very bright. And there are species that perceive in the infrared part as well. So here are some examples of those. If that's how humans see it, how these things, this is how humans see that. This is quite often how animals see the same scene. And then, of course, there's aspects such as polarized light. Right? These are computer generations that show that there are different bandings from our point of view, and then you can use colour to represent that. See the clouds here showing how the light is polarized. But those that use polarized light and magnetism to navigate, you can see that that bird looks in that direction, certain pattern, but if they're actually looking in this direction, the pattern will change. And so we have no idea that. We can't see it. So how can we protect against the problems we're creating? And just because I like the good old dung beetle, this is a well-known example which has been reproducible in one of Field Surprise. They realised that a humble dung beetle used celestial navigation to find his way home once he got into the pile of dung. So, now, unfortunately, this lady was recently classified in the media as being murdered at the age of 92 in a nursing home. But that might be just very, very clever lady. That might just be the media, I don't know. But this is one of the things that she had come up. She worked for the CSIRO for many years and said if this was the sum of what they defined as life on Earth, 60% of it is bacteria, 40% are life forms that we recognise. Look, of all the things that we relate to, animal kingdoms, this tiny little speck here, and we're just even a pinprick in that, and yet we are dominating everything that's happening. Because artificial light is solely for human benefit. It is not there for the benefit of insects and plants and so on. It's to grow plants for our food source. So, and if we only know a little bit about a few things in this area here, what hope have we got of reducing our impact on the rest of this? That would be my concern. So the question is, could the problem that happened in Biosphere 1, which is where we live? The question, I don't know the answer to that. But IS4282 was the first national attempt at limiting light spills. It was an Australian thing and first one in the world. The CIA subsequently copied it and then modified it to their own benefits. But it was very, very controversial at the time. Extremes of this is not gone far enough, it's a load of rubbish, to the other extreme that said you're going to kill the whole of industry, you're mad, and both parties are offering threats to those that were involved. There's a new version come out in that, but there is a process. Standards are primarily recommendations unless they're legislated. And so if people don't use a standard, what happens is the standard disappears. So you've got to get parties together to do something till they experience it. And then go, oh, it's not as bad as we thought, we can do that. Well, that's what happened with 4282. And first, that's the first time it was ever put out as a preliminary standard in 92, just to see what was going to happen before it was actually published formally as a standard in 97. 20 years later, it's being modified again. And okay, it might not be to everybody's satisfaction, but it's trying to make sure that that document is used. The current one that's there, which will shortly be replaced, has been misused in many ways because there's no other thing that people can use to say you must comply with some standard. The only reason why I put that in there is ALAN conferences are really great because you've got all these people coming together with different opinions, and you need to respect those opinions. It didn't happen at that time. That was best not to go into. That's not a theory flying anymore. That's an acronym for Best Available Technology. Unfortunately, there are quite a few papers and publications out there that, due to lack of funding, indicate that this is what we found in a limited way, and therefore our guess basically is this is what it should be. You can't use that information in the stand. It's got to be things that are being reviewed and can be And also check the facts. Even in the recent one, there've been, because somebody's just seen a figure and think, you people have gone backwards, are you nuts? You've raised the value, but that's the value at a certain angle. And if you check it against the original one was a reduced value, but at a higher angle. And when you check the performance of this other one, it's actually less, even though the number looks bigger. The reason is Australia is this part of the world, and for free trade agreements, we have to have things that work together, otherwise they're barriers to trade. So we need to relate to these things. Complete change. Has anybody read this book? It's a publication written. That is the real Bill. And it's endorsed in front of the hearing. But what's really interesting, yes, it's a novel and it's a fictitious thing about what would happen in certain computer things happen in time. But that's just a story about how the different forces and different people interact and they have their own interests rather than interests solving problems. And his conclusion, interestingly, was we need to get rid of the us versus them. So, I'm the one talking about us versus them or us versus them. We need to solve the problem. Our problem is light spill, excessive light. Our problem is inappropriate light at an inappropriate time. So, as he said, what he was drawing on presidential time was we should be working together. So, what I would recommend is this. But instead of centres being offered to change to LED, which is without qualification most of the time, and everyone's grabbing these financial incentives. That's what it's about. It's about economy, about making money. It should be the incentive is only offered if the lighting is appropriate, where needed, only when needed, and with minimum environmental effect, not about just saving energy. And my other recommendation would be invest in more research. So I really like our conferences because we come together and we discuss things and respect each other's opinion and we get and so you can see that technology has changed. Yes, we are rising it, but we need to make sure we address positive aspects as well as negative.
I've got time for a couple of quick questions. Remember, there's always time this afternoon in panel session or before dinner when we're up in the mountain later. Have a lot more questions and informal chats.
If I was going to play devil's advocate, I would say we're behind the eight ball right now, in that it's being rolled out throughout Australia. So how do we change that conversation rapidly? Because I appreciate everybody wants to do that, but how do we work together?
Yeah, I understand clearly what it is that you're saying, but I just have to be careful of how I answer it. Yes, I understand we want to be in front of what's happening rather than behind them. But unfortunately, if it's to do with standards, it tends to be behind because you can only write and put things in Australian standards which are backed up by research that is being reliable and being visited by others and being proven. So that time element, unfortunately, is of an issue in that regard. The only other way you can overcome that is to make something that's legislated, but people still will ignore it. Right? You've got Siding Spring Plan, which is legislation, but people go and they just ignore the requests. You can't. So it's a process. I understand it because I would have liked stuff and but I'm patient.
I think the way we need to talk about light now is that we are losing one of the most important ecosystem services darkness as an ecosystem service. This is the need. This is one of the ways we need to look at it. And we are going to miss insects. Missing insects means missing pollination. Missing pollination means maybe no food. And these are points that we are not talking about. They are too broad and not so comfortable. And therefore, when I suggested talking about sustainable illumination, we cannot have illumination which goes against ecological principles.
In the new version 4.2.8 that will be out shortly, it's been out for public comment, and that's been revised and it'll be published, I don't know when, it's supposed to be August of last year. Should be hopefully sometime this year. When they publish it, at the moment the concession to that is that there's an appendice that people can refer to, indicating that they need to consider the environment of various species. It doesn't go specifically into them because it needs solid research to say this species is such and such. But we've got experts, some of them in this room, that can tell you more about those particular species. But I agree with you, these are issues, but everybody likes their mobile phone and their laptop, and they like to go and play their sport and have their beer and, you know, yell at the kids and everything else that goes on before it's life. So it's how we meet the balance. And the last thing we want to do is leave a legacy where, you know, in 50 years' time, your children or your grandchildren are back and God, what did my grandparents do? What do they leave us with? You know? So I agree with you, they're important issues.
All right, let's thank Tim.